right. It's time for some more rational functions review. And I have this sneaking suspicion here that this lesson is going to be twice as fun, twice as exciting. You want to know how I know that? Double exclamation points. I didn't put that in there for no reason, right? There's two of them. I want you to remember that, all right? And Jenny here is twice as excited. Actually, her excitement is approaching negative infinity, I feel like, right now. But that's okay. You know, she's here for moral support. We'll pop in there with Jenny as usual. So how do we start these problems here? How do we start our wonderful rational functions? It's with look at that. She popped up again. It's factoring. She's like, oh, let me adjust. All right. Factoring time. She had a big puppy size. She's like, oh, factoring. It's my fave. So I have x minus 1, and then I have x plus 4, x plus 1. Now, in this particular situation, nothing is canceling out, which means we don't have any holes in this one. But let's go with that domain. My domain is going to be x such that x does not equal -4 or -1. You could also write an interval notation, right? I'm going to skip over the range for now until we get to the graph. What I'm going to go down to is f, my vertical asymptote or asymptotes. Well, we don't have any holes, nothing canceled out, so I actually have x equals -4 and x equals -1. So both of those are going to be asymptotes. I can pop that on the graph right now. I'm going to do my asymptotes in pink. All right, so they would show up real nice. So I've got -4 and -1. Awesome. That's interesting. We don't see that every day. 2 asymptotes, 2 verticals. Oh, man. All righty, next. So no holes. Horizontal asymptote. Remember our rules from last time? They are right here. We have small over large, which is y equals 0 again. Okay. Let's see here. Next up, x-intercepts, y-intercepts. That's right. Let's do that. We got that on D and E right here. So x-intercepts. Well, if I want to get an x-intercept, that means that my function value, my y value is 0, right? If it's crossing the x-axis, that means y is 0. So anywhere along here, -3, 0, -2, 0, 0, 0, 1, 0, 2, 0, 3, 0. My y value is always 0. So I'm going to set this equal to 0. And when I'm setting it equal to 0, I obviously don't want my denominator 0. We can't divide by 0. I only need to focus then on my numerator equaling 0. So I can take my numerator, I'll add 1, and I'll get 1 for x. So my x-intercept is 1, 0. Okay? I only need to focus on my numerator there because I don't want my denominator 0. That would make it undefined, right? So I pick and choose what I need based on what I know about functions, right? So for my y-intercepts, my y-intercept, there's only going to be 1. What do I do now? Oh, that's right. My x value would have to be 0 if it's on the y-axis, right? So I'm going to go ahead and plug in 0 to my function here. It's easiest when it's in its original non-factored form like we have here, because again, I can just focus on those two. -1 over 4, because everything else is going to be 0 and gone. So it'd be 0, -1 fourth. Awesome. So it might help if you want to jot down that when I find my x-intercepts, I set the numerator equal to 0. When I find my y-intercept, it's when I set x equal to 0. But I think it's really, really important to understand why. Not that somebody just told you, well, you plug in 0 for the other one, then you get that one. Like, that's great and all, but we should know why and what it looks like on the graph, right? That helps us retain the information. I think I'm ready to graph this thing, so let's do that. I've got my vertical asymptotes. Let me pop on my horizontal now. Whoa, I got a little off track there. Wonderful. Put some arrows on these bad boys. Awesome. Remember, those are equations of lines. That's why we write them x equals -4, x equals -1, y equals 0. They're equations. Wonderful. So let me plot some points that I have here. I've got my my y-intercept of 0, -1/4. So that's right here. I've got an x-intercept of 1, 0. That's interesting. An x-intercept, excuse me. Yeah, 1, 0. Cool. Which is right there. Very interesting. It's on the asymptote. Okay. We're gonna talk about that in a little bit here. You see, it surprised me when I was like, wait, did I make a mistake? No, it can happen, kids. It can happen. It's happening today. You go learn today. All right. Now, anything else that we have going on here? Not that I can graph, right? Not that I can graph. I've got everything on there that I know. All right. So now we got to figure out what the heck's going on. So I can see, generally speaking, with these 2 points that I'm going to have something like this. What actually happens is it comes up and then it comes back and it approaches right here. And what I would like to do is after we get this thing plotted, we're gonna explore what's going on here. Okay, we're gonna explore that one as to what's happening. All right, so now what's going on with the rest of the graph here? Well, let's look at this middle section. Okay, that's interesting, right? Well, if I go to each side of the asymptote, so I'm on the left-hand side of this asymptote. So I'm approaching from the right. Let's see here. Approaching from the left. If I go real close to that, to the left of -1 would be like -1.1. So if I were to plug in -1.1 to my function here, and I'm not even really worried about, I'll do these in a different color. I'm not even worried about the actual value, but if I plugged in -1.1 minus 1 over -1.1 plus 4, -1.1 plus 1, I'm going to have a negative in the numerator over, this would be positive, and then this would be negative. So what's my overall signage here? It's going to be positive, which means my graph would be, as it approaches that, would be going to positive infinity. So that's part of that section. Now, if I do this side of my asymptote, right to the right of the -4, I'm going to be plugging in -3.9. And if I do that, I would have a negative, a positive, and a negative. Same situation as over here, right? And it's nice if you can do the math quick. We're not worried about the actual number, just if it's positive or negative. So negative, positive, negative. That would make it positive as well. So what's actually happening here is you're going to have this little kind of a U-looking shape type dealio, okay, where it's going up there. All right, and if I get real close to that asymptote, that horizontal, it's doing something like that. We could plug in some other values to get some points if we really wanted. I'm going to leave it at that for now. Now, the other portion, let's find out what's going on. Well, if I go to the left of -4, that's -4.1, and if I use my little sign chart action, negative in the numerator, negative here, and negative here, 3 negatives, that's going to stay negative, which means that my graph is like that, and it's going to come up. Boom. There we go. We have ourselves a nice graph. We used intercepts. We used values close to our asymptotes to see what was going on. And we've had some success here. Now, what I would like to do is I'd like to use the calculator a little bit to verify this. If I were to pop this on and graph it, yeah, it looks something like that, right? It kind of disappears over here, which is interesting. But remember I said that I wanted to check out what the heck was going on here, like how it went through and up. Right, because it started down here, started from the bottom, and now we're here, Drake. But it comes back down, and it's hard to see. But if I go to my table again, and I hit second table, actually I got to set it to ask, so second table set. And if I hit, ask, there we go. I might have to just clear the table. There we go. Got it cleared. So if I plug in some values like, let's just say, how about 2? Not Z. We want 2. Hit enter. Oh, I get a positive number, right? Interesting. So it is above my x-axis. And let's say I plug in 10, so something a little bigger. Okay. So it's still larger there. What if I go to Let's say, how about 50? Ooh, it got smaller. So it's, and then if I keep going, let's go one more before I make a conclusion here. Even smaller yet, right? So what has happened is it's gone up and then come back. And it may not have happened like is drastically right here, right? We saw that it was still getting a little bigger by 10, but it happens in like kind of like a bump like that, okay? Now, if I check out the values over here on the left-hand side, if I say plug in negative 100, negative 100, what am I going to get? Well, hopefully I would get, see, I got a negative number there, right? It stayed below the asymptote on that side. Cool. And we could go ahead and take a look at what was going on close to our vertical asymptotes as well if we wanted. So let's do that. Let me clear it out again. All right. So I've plugged in the values for you guys here so we save a little time. So this is the scenario right over here as we were trying to figure out what was going on with this portion of the graph, right? Is it going up and approaching positive infinity or going down and approaching negative infinity? And when we did that one, we did that sign chart, we found that it was actually this very scenario right here. We plugged in negative 1.1 and we found that it was negative over positive times a negative, which became positive. And the same holds true here. My numbers are just getting larger and larger and larger. So perhaps as a test question, we could say, given this table of values, what's happening in our graph? What can you conclude about the graph? Well, you could say, well, it appears that there's going to be a vertical asymptote at x equals negative 1, and the graph, as it approaches from the left, is going towards positive infinity. That's a lot to conclude from these numbers, but you can do so, and we can make that connection from the table of values to our actual graph over here and see that connection that's happening, rather than just, oh, I plug this in, boom, I do that, boom. It's nice to have some numbers to work with and see how it's all working out here in a table as well as graphically, right? We want to make those connections in an advanced course such as this. All right, awesome, fantastic. Let's finish out our end behaviors that we were doing. So as x approaches, maybe I'll actually do negative infinity first. I don't know why I did positive last time. Then f of x is approaching 0, right? That's over in this section. And as x, I did that last time. Forgot the s. F of x is once again approaching 0. It just happens to be on top of the asymptote, right? But it's still approaching. It's getting infinitely closer. Now, as they go to the vertical asymptote, so we'll deal with, let's deal with negative 4 first. So as x approaches negative 4 from the left-hand side, we're talking about this section right here. It's going to negative infinity. F of x is approaching negative infinity. Whoa, what was that infinity right there? As x approaches negative 4 from the right, and this is nice notation here. They're going to use that in calculus, so we want to introduce it to you now. But as it approaches from the right, it's going to positive infinity. Then our other asymptote, as x approaches negative 1 from the left, that's where f of x is approaching. Well, as it comes in from the left, we're going on this stretch of the graph. F of x is going once again to positive infinity. And then lastly, as x approaches negative 1 from the right-hand side, f of x is approaching. Well, as it comes in from the right, going to negative infinity. Wonderful, fantastic, excellent. I love it. Got our end behavior. We got our vertical as the behavior as it approaches our vertical asymptotes. All good things. This is a lot of information here, you guys. A lot of information. And you know what? I just realized we forgot one piece. So I'm going to do it in its own special color. If it will let me select my own color. Here we go. What is our... Ooh. I'm going to go with this one. What is our range? I forgot to say our range. Well, for this particular one, we'd actually need to find a minimum here. My goodness. That might be more than we want to do, but what the heck? Let's do it. Actually, you know what? We're not going to do the range on this one. I just decided. Freebie day for you guys. It would involve a bit more than I think we really want to get into right now. So we will leave it at that. I hope you guys had a fantastic time with this. I know I did. Have a great day. We'll see you in class. Jenny will. Jenny's not allowed there, but there you go. She's snoozing. Jenny. Oh, what up, Jenny? You want to join in on class? Want to do some pre-calc honors? Okay, maybe not. All right, guys. Have a wonderful day. America, freedom, rock and roll. Costco.